Let us make a program for printing even numbers, odd numbers and prime numbers. We want to give the user 6 different options. First option will be to print first n even numbers. Let us say user enters 10. So we will be printing the even numbers, 10 even numbers starting from 1. If the user says first n odd numbers and he enters, let us say 15, then it means that we want to print 15 odd numbers starting from 1. Similarly, first n prime numbers means first n prime numbers starting from 1 had to be printed. Then next option we want to give the user is print the even numbers between user defined range. So if the user says 21 and 91, then we want to print the even numbers between 21 and 91. Similarly, if he says odd numbers, then odd numbers between 21 and 91, and similarly prime numbers between 21 and 91. So these are the 6 options which we want to give to the user as per his choice. First of all, we will be including 2 header files, iostream.h header file and conio.h header file. iostream.h header file will be used for input-output streams, namely cin and cout, and conio.h header file will be used for the functions like getch for get character, which is used to hold the screen, and clear screen, clr scr. So for giving the choices, we can make use of switch case statements. Now if we want to repeat these activities again and again, then we should put these activities, the set of statements between a while loop. Now we want to enter the choice from the user. We want to take the choice from the user. So let us declare one variable choice of type integer. Now for the first uh, for the first three choices, we want to enter only one number, and for the fourth, fifth and sixth choice, the user have to enter two numbers. So let us declare again two integer variables for this purpose. Next, we will be making use of switch case statement for switching to the choices. Now for the case 1, that is for the first choice, we want to print first n even numbers. So let us define the function for it, f underscore even, and we will be passing one parameter number 1 no1, which has been entered by the user. Similarly, for the second and third choices, we can name the functions as f odd, that is first n odd numbers, and f underscore prime for first n prime numbers. So for the case 2 and 3, all the things will be same except the function name. So let us name it f underscore odd and f underscore prime. Now from the case 4, 5 and for case 4, 5 and 6, we want to enter two numbers from the user. Now for case 4, 5 and 6, we would like to enter two numbers from the user. Now let us name the function as r even, r odd and r prime for remembering us that it is range of numbers. Okay, so this completes our entering the choices. Now if we want that this continuously repeats, that is the until and unless the user enters 7, then we would be including all these statements within the while loop, while choice is not equal to 7. when we have declared integer choice, then it can have any random number. So let us give it some specific number. Let us say we want to give it to be choice equal to 1. Now let us compile the program. Let us save the program and then compile the program. We are naming it like for even, odd and prime. So we are taking first two characters from each, EV, OD and PR. Okay, now there are errors since we are making use of these functions and we have not yet defined these functions, so we have to declare them before these functions can be called. This is also known as a prototype, function prototype. So we have to do it before void main. Let us again compile the program. Yes, so we got the success. Now let us define the functions. Let us run the program first of all. So by pressing Ctrl F9 we can run the program. Okay, so we have to write like this. Now let us see whether our logic is correctly working or not. When we enter 1, it asks to enter one number, let us say 12. Okay, so it is again repeating and giving us a chance again. Since we have not written anything inside the function, that is why nothing is being printed. Let us enter 2. It is again asking for one number, let us say 3. Okay, now let us enter the choice 6. Now it is asking for two numbers, let us say 12 and 45. Okay, it's again correctly working. Let us enter 7. Okay, so the program logic is correct. Now we have to define the functions. So for printing the first n even numbers, the logic which we can use is we can use one while loop. We can have one variable count which will be keeping count of whether we have printed the expected number of even numbers or not as per the user requirement. So we can put like this: while count is less than number, and we can initialize the count by 0. The variable no, which has been entered by the user, so the count should be less than that number. Since we are starting the count by 0, if we would have started the count from 1, then we would have written count is less than or equal to number. Let us again take one number, one more variable. Let us name it even, which will be incremented one again and again, and we will be checking whether this number, the number which this even variable is holding, is even or not. If it is even, then we will print. If it is not, then we will skip it, and we will increment the even by again 1, so that the next number can be checked. Okay, now again we want to print the numbers in such a fashion that they should be separated equally. The space between the two numbers which are being printed should be equal. So we can make use of another function, go to xy, which moves our cursor as per our requirement. So go to xy, then in the bracket we can write the column number and comma row number. So we again need two more variables, column and row, because we need to increment them after each number is printed. So the logic is simple. We are checking this number even, which we have initialized by 1, by even mod 2. So if even mod 2 will give us the remainder after dividing this number even by 2. So if it's an even number, then whenever we divide it by 2, then the remainder will be always 0. So we are checking that thing only. So if even mod 2 is equal to 0, then it means it's an even number. So we are making use of the function go to xy, bracket, inside the bracket column comma row, which we have initialized by 1 and 1. So the first number will be printed at column 1 and row 1. In the C++ screen, there are 80 columns and 25 rows. After printing the even number, we are incrementing the count by 1 because we have printed one even number. Okay, so this completes our logic. Now the last thing which remains here is we have to increment the even number by 1. And get ch we are making use of for get character function, which is used to hold the output screen. So we have to increase the even number inside the while loop, because whether it's an even number or not, it doesn't matter. So we cannot increment the even number inside this if loop. If it is even, then it will be printed. If it is not even, then we will skip that number and simply we will increment the even. So in both the cases, whether it is printed or not, even number had to be incremented, which we have initialized by 1. And we will be repeating this until and unless the count becomes less than just number, or the count becomes equals to number, since we have started the count by 0. Let us compile the program and run the program. Okay. Okay, so let us test. Enter the number, first and even numbers. Let us say I want to print first 2 even numbers. Okay, so it has printed 2 and 4. We should have done the clear screen also. Okay, so let us quit and we should first of all clear the screen. Okay, first and even numbers. We want to print first 2 even numbers, 2 and 4. Okay, let us again select 1, enter the number. So we want to print 50 even numbers. Okay, so you can see that by using this go to xy, we are spacing the numbers in equal, with equal space, with a space equal to 7. Okay, now let us quit. Okay, so for printing the odd numbers, the logic will be same as even. Except some minor changes. Okay. So the variable name now we can make as odd, So now here we will be checking the odd number. So if odd mod 2 is not equal to 0, then it's a odd number. Out odd. Rest of the logic remains same. Here also the variable will be changed to odd. Okay, now let us test the program. Let us enter the choice 2. Enter the number. Two odd numbers. Okay, 1 and 3. 8 odd numbers. Sorry, 1. Enter the number 3. Okay, 2, 4, 6. It's a even, right? Select 2. Enter first 8 odd numbers. Okay, so it is correctly printing. Again 59 odd numbers. Okay, so it is printing correctly. Let us now build the logic for prime numbers. Okay, the prime number will be having a little different logic. But let us again copy it. We will make the changes accordingly. Okay, now the first prime number is 2. So let us print the 2 first of all and adjust our columns and row accordingly. After that we will apply the logic. The logic will be this: if the number, the prime number, is divisible by 1 and the number itself. So 2 is the exception for that, because 2 is the prime number but it is divisible by 1 and 2 itself. So that is why we are printing 2 first of all. After that the logic will be correctly working. Again, one more thing, let us say if the number is 11, so we should not, for checking this, that the number is divisible by 1 and the number itself, we need not apply the logic to check it from 2 to 10. What we can do is simply divide the number by 2. So in our case it is 11, so 11 divided by 2. The integer division will give us 5. The float division or the float value will be 5.5, but when we do the integer division, when we divide two integer numbers, then it removes or truncates the decimal part. So dividing the 11 by 2 will give us 5.5. If we do integer division, then it will give 5, since the number is coming to be 5.5. So now the logic should be like this, that if this 11 is divisible by 2 to 5 by any number, then the 11 is not a prime, otherwise it's a prime. Because after that, if we increase the number by 5 by 1, then it becomes 6. Now 6 into 2 is 12, which is more than the number itself. So it is not possible to divide the number by 6 or any number higher than 6. So our calculation will be faster if we apply this logic also. Otherwise this logic will also work, that simply divide the number from 2 till number minus 1. This logic will also work, but it will require more time. Computation time will be required, will be more. So our initial value of prime will be 3, because 2 we will be printing. Okay, so here the logic will be different. The same logic which we have just now discussed. So first of all, let us find whatever number it is, number divided by 2, that we can store in some variable, let us say n. Now we require one for loop which will be going from 2 till n, and from 2 till n, if that number is divisible by that number between 2 to n, if it is divided, if it is divisible by any of these numbers, then it's not a prime, otherwise it's a prime. So for checking whether the number is divisible by any of these number between 2 to n, what we should do is we should divide, we should find the mod value of prime mod I. If it is equal to 0, then it's not a prime, otherwise it's a prime. Okay, we require one more variable. We can name it as a flag. So if our number is divisible by this I, prime is divisible by I, then we will set the flag to be equal to 1. because after the for loop we will be checking if the flag is equal to 0 or 1. If it is 0, which we will initialize it with, then it means it it is never gone inside this if loop, inside this if condition. And if it has not gone, then it's a prime number. And if it is gone, then flag must have been set it to 1. Then it's not a prime. So we will come to know. Break will break this condition, and it will come out of this for loop immediately, because there is no further need to divide it by or check the divisibility by any other number. If it is divisible by even one number, then it's not a prime. We come to know that. So we set the flag equal to 1 and then we break from the for loop. Okay, after this the logic remains same. Count plus plus will increment the count, that is we have found one prime number. After that column will be incremented again. The logic will be same. Change the variable from odd to prime. And again initialize the flag by 0, because it becomes ready for the next loop. Now let us again look our logic, what we have done. So clear screen, integer count equal to 0, then integer prime is equals to 3. We have initialized the prime number by 3, this variable by 3, because we are going to print the 2 by ourselves. Okay, so here we have printed, then we have incremented the column by 7, we have initialized the flag by 0. Next we have find the n, which is prime, divided by 2, and we have applied the for loop from I is equals to 2 to I less than or equal to n. So if it is divisible by any of these numbers, so for that we are checking if prime mod I equal to 0. If it is divisible, then we set the flag equal to 1, otherwise this for loop continues till I becomes equal to n. After the for loop we are checking the flag value. If it is 0, then it means it has never gone inside this logic, if logic, and it means it's a prime number, so we should print it. So we will be moving our cursor to column comma row, then print the prime number, count is incremented, again the logic is same, column is again incremented, the last we will increment the prime by 1 and then flag value is again resetted to 0. Okay, the logic seems to be okay. Let us run the program. Okay, now let us try the third option, first and prime numbers. So if I want to print only one prime number, then it is printing 2 and 3. Okay, we have to see. Okay, let us quit the program. The mistake which we have done is, since we are printing one number 2 already, so the count value should not be 0, it should be 1. Okay, let us again run the program. Option 3, enter the number, one prime number. Okay, 1 is printed. Again the option 3, 2 prime numbers. Okay, again the option 3, 7 prime numbers. Okay, again the option 3, 67 prime numbers. Okay, so the logic is working correctly. Now let us try the other 3 functions. Okay, so here what we have to do is, we are having 2 numbers entered by the user himself, so we don't require the count variable here, and we don't require this. Also we don't require even variable. Why we don't require? Sooner we will know soon. We also don't require this while loop. In place of that we will require for loop. So for I is equals to number 1 till I is less than or equal to number 2, I plus plus, and here we should check I. See out I, we don't require this count. We don't require this even variable. Now this is not a while, it is for loop ends. Okay, this is all I think we will be requiring. Let us again see the logic what we are doing. Clear screen, then column and row are initialized to 1. Now we apply the for loop from I is equals to number 1 to I less than or equal to number 2, and we are again now checking I mod 2. If it is equal to 0, then it's a even number, so we will be printing it, and if it is not, then we will simply continue the for loop. That's it, the logic. Let us test our logic. Okay, so fourth, now we want to print the even numbers, let us say between 21 and 89. Okay, so it is correctly printing. Now let us build our logic of odd numbers. Now here our logic will be if I mod 2 is not equal to 0, then it's an odd number, so we'll be printing it. I think rest of the logic remains same. Okay, let us try. So the option 5, let us say the odd numbers between 22 and 110. Yeah, so it is correctly working. Quit. Now let us build the logic for prime numbers. Okay, we should copy the prime logic from here. Okay, now since again we want to print the prime numbers between two numbers, so we won't be requiring the count. We also don't require this prime variable. Okay, now if the user has entered the number 1 as NO1, then 2 should be printed, but our logic won't be printing 2. So we have to check if NO1 is equals to 1 or 2, and if it is so, then in that case we have to print the 2. can use another logic also. If the number 1 NO1 is 1, then make it 2, and then we can use our for logic from j equal to NO1 to j less than or equal to NO2 j plus plus, and rest of the logic remains the same, and I think it will work correctly. Okay, let us try. We don't require this while loop. We will be using the for loop instead. So for integer j equal to NO1 till j is less than or equal to NO2 j plus plus, and this is our for loop. For loop ends here instead of while, so for ends here. Now okay, let us try simple logic. After that we'll see if NO1 is equal to 1 or 2, then what happens. So here n is equals to j by 2 instead of prime. It is j by 2 instead of prime. Then for integer I equals to 2 to I less than or equal to n I plus plus. Okay, so if j mod I equal to 0, then flag equal to 1 and then break. For loop ends here. If flag equal to 0, then print j. We don't require this count plus plus. We don't require this prime plus plus. Flag equal to 0. Okay. It will work for numbers greater than 2. If NO1 is greater than 2, then it will work correctly. Let us see. Integer n is j by 2, flag has been initialized to 0. For integer j equal to NO1 till j less than or equal to NO2 j plus plus. For integer I equal to 2 to I less than or equal to n I plus plus. Okay, so we are checking. J is here NO1 number 1. So if the number is starting from 3, so it is 3 by 2, that is the answer will be, integer division will be giving us 1. So for I is equals to 2 to I less than or equal to 1, it will simply discard it. Okay, so flag will be remaining 0 in this case, and we will be printing 3 here. What happens if j is equals to, if NO1 is equal to 2, then in that case 2 by 2 will be giving us 1, n is again 1, so I is equals to 2 to I less than or equal to 1. Again it will not go, so here we don't require anything. I think it will work correctly for any values of NO1. Okay, let us try. Now we want to print the prime numbers between 2 and 10. So 2, 3, 5, 7. It is correctly working, right? I want to print the numbers between 1 and 10. So it is now printing 1 always. Okay. So the logic fails if NO1 is equals to 1. In case NO1 is equals to 1, then we should do it 2. That's it. Okay. So 7 quit. If NO1 is equals to 1, then make it 2. Right. Okay, now the logic works fine, I think. 6, print prime numbers between 1 and 100. So 2, 3, 5, okay. Yes, so the logic is now correctly working. Let us see the logic once again. Okay, so first of all, clear screen, column and row are initialized to 1. Then we have taken variable n, flag is initialized to 0. If NO1 is equals to 1, then NO1 make it 2. Because in this case, our logic will not be working correctly. It will be printing the 1 also. And 1 is not a prime number. Now for integer j equals to NO1 to NO2, that is the user defined range. Then n is equals to j by 2, that is the number divided by 2. So we will be checking the same number from I equals to 2 to I less than or equal to n. And if it is divisible by any of these numbers, that is j mod I is equal to 0, then flag is equals to 1, otherwise flag remains 0. Here we are checking if flag equal to 0, then print the number. In the last, we will be initializing the flag again, so that it becomes ready for the next iteration. Okay, so that completes our program.